Okay, I'm going to read to you guys from the next section in the art of mathematics in business. So, first we have the idea of an effective interest rate, and the boilerplate for that is it says real interest rate, but we can also call that the effective interest rate. E for effective is equal to the nominal interest rate, nominal interest rate divided by net proceeds of loan. Of loan. So that means how much money they're getting back at the end of the day. Net proceeds, so of loan. And again, E here, I'll just write it out, is effective interest, and T-E-R-E-S-T rate. Okay, so for example, we have a discounted loan, which is a common form of loan. Interest is deducted immediately in arriving at the net proceeds, which increases the effective interest rate. A bank may require a compensating balance. So a compensating balance, which is really just, in other words, a deposit that offsets the unpaid loan. In this case, no interest is earned on the compensating balance, which is stated as a percentage of the loan. A compensating balance, so this is the reason why the bank likes it, a compensating balance also increases the effective interest rate. So first, this is a deposit that you make up front. So in theory, the bank is making money off of that interest right at the top. But other types of loans don't require that. So why? Well, in this case, it's short-term financing where it's more common. And the reason being is that all things being equal, money today is worth more than money tomorrow. That's called the time value of money. So if I have $300 and I loan that $300 to you, while there's an opportunity cost, I'm defraying my ability to buy stuff with that $300 today by loaning it out to you to, whatever you're going to use the money for. I can't use it for anything. So I can't go out and buy an Xbox or a bike. I can't do anything with that. So what I do is I charge you an interest rate. So when I get the money back, I'm compensated for the lost opportunity that I had to use that money. And it's also possible that the money uh, isn't going to go as far tomorrow. It may be that things like bicycles and Xboxes are going to cost more money. So I'm going to need a little bit more money to be able to buy those things. So I might as well get compensated for higher prices tomorrow when you pay me back the loan. And then the longer it takes for you to pay back the loan, if I'm loaning you money over a year versus 10 years, well, then it becomes less likely that I'll get the money back the longer the time period. And not to mention that there's a higher risk of me getting the money back, but that opportunity cost is building out. Prices may be even higher in 10 years than they would be next year. So I'm going to charge a higher interest rate. And the interest rate that I charge you, the effective interest rate, is the price. And just like you want to make sure that you're paying the lowest price for something that's the same, if I'm selling an apple and somebody else is selling an apple, and it's the same apple no matter what, well, you want to make sure you don't pay any more for that apple because my apple's no better than their apple and their apple's no better than my apple. They come from the same orchard. They're not literally the same apple, but there's no material difference between those two apples. So you might as well pay the same price. And if you're borrowing $10,000 from someone, it's $10,000. It doesn't matter if I'm loaning $10,000 and you're loaning $10,000, it's just $10,000. So you might as well pay the lowest possible effective interest rate for that $10,000. And again, you can think of this as the price the bank is charging, so it's how they make their money. So just like if you had a lemonade stand and you have a cost of lemons and sugar and maybe you built your own table and materials or the tablecloth that you went out and bought to put over a little card table that you borrowed from your mom or whatever. But at the end of the day, let's say it cost you $300 is equal to $300. And let's say you made a profit, a revenue of $700. Well, your profit is going to be equal to profit is equal to cost, C for cost, revenue, R for revenue, minus C for cost. And that's just going to be C, or R is $700. So we're substituting R for $700 minus C for $300. 700 minus 300, just like 7 minus 3 is 4. 700 minus 300 is $400. Okay, so now that explains why we're making the compensating deposit, because when you make that compensating deposit, it means when we go back to the net proceeds, we're deducting another thing out of the net proceeds, which means we're going to have a smaller number here in the denominator. And the smaller the denominator, then the higher the percentage, the higher the ratio. When we divide x by q, the smaller q is, the lower q is, the higher, as this goes down, if x divided by q equals r, then the lower q is, the higher r is. And they want the highest possible price, but you want to pay the lowest possible price, so that's why you want to shop around if you can. And that's why you want to know what the effective interest rate is. So in this example, a business takes out a loan of $10,000. So if you take out a loan of $10,000, that means the principal, how much you're borrowing or how much someone's lending, is $10,000. So P for principal equals $10,000. And then it's over 1 year. So say T equals 1 year. And then it's a 10% discount loan. I'm just going to say that R for rate equals 10%. And then the compensating balance is 5%. So C is 5%. Well, what we're going to do is take, in order to figure out what the effective interest rate is, we're going to take the nominal interest rate. So the nominal interest rate, N, would be equal to 10% of the principal, which would be 0.1 times $10,000. And again, if we're just moving that over one decimal place, that's just going to be equal to $1,000. So N equals $1,000. So we'll just rewrite that as n equals $1,000. And then we want to figure out the net proceeds of the loan. So that's going to be the principal minus the nominal rate, which is $1,000, minus this compensating deposit. Well, the compensating deposit is just 5% of the $10,000. So D, which is 0.5 times $10,000. Well, if 10% of $10,000 is $1,000 and 5% is just half of 10%, then 5% of $10,000 we know is just equal to $500. $500. So if we're taking the nominal interest, which is, or the cost of the nominal interest rate is, I suppose how you should think of that, because it's 10%, but what you're paying is $1,000. So $1,000 divided by the net proceeds. Well, the net proceeds is going to be P, the principal, $10,000 minus N, which is $1,000, minus the deposit, D, which is $500. Well, 10,000 minus 1,000 is 9,000, and the 9,000 minus 5,000 is $8,500. So we have, write that down a little bit lower. That's going to be equal to 1,000 divided by $8,500, and 1,000 divided by $8,500 is equal to 0.11764, 0.11764. And if we move this decimal point over two places, just like if we had 0.5 to make that into a percentage, we just go over two places, put in a 0, and we'd have 50%. So two places, we'd have 11.764. If we just round up, the 6 is bigger than 5, so we'll just turn the 7 into an 8. And on our calculator, if we forget that, most scientific calculators, like the one you'd have on your iPhone or Android or your Mac or your PC, should have this as well. And boom, it does it for us. That's 0.0011. So, well, actually, that's not doing it for us. So don't do that trick. Anyway, regardless, you have 11.8%. That's your percentage. And if you have a bank that is charging you 9% as the effective interest rate to borrow $10,000, then go with that bank, because they're charging you less money for the same thing. And there's no reason, all things being equal, there's no reason to pay more than you have to for the same thing.